coming up this week?
So the cell that we just introduced, it's 370 watt hours per kilogram, 10C continuous capable, at least 15C pulse with no cooling. Next generation batteries are here now, commercially available, right? Price market benefit.
Well, hello, friends, and welcome to the EV Resource Podcast. I'm Zach Hurst, and each week I bring you the latest EV news, information, and interviews with industry experts. And this week I have Ronnie Tao, the VP of Business Development for Amprius Technologies. And we're going to get into talking about EV batteries, but not necessarily for what you'd think in your car. We're going to be talking about how EV batteries are so vital to the transition of electrification for the aviation industry. So it's going to get really, really exciting. And I know Ronnie is super passionate about it, so I'm excited to talk to Ronnie. Before we get into the depth of our conversation, Ronnie, I want to give you the chance to introduce yourself and talk about your background, speak to your origin story, if you will.
Well, yeah, it's a pleasure to be here, Zach. The brief introduction, my name is Ronnie Tao. I'm the Vice President of Business Development here at Amprius. I've been in the battery industry for about 15 years now. I'm a little bit of a unicorn in the battery space in that I'm one of the very few individuals in the world who's been on all sides of battery, from cell manufacturing to pack assembly to the customer buy side. I cut my teeth in the industry through industry titans back, with Sony Energy, back when there was still Sony Energy. I actually was on the customer buy side, really helping stand up Amazon at Lab 126 whenever they were really first starting off and getting batteries into their devices, really helping put together their battery strategy. And then went over to a couple of battery pack houses to really, go full circle, right? So being able to look at every opportunity, whether it be, automotive based or aviation based, I tend to kind of look at it from every single direction so that when customers engage, their solution is already well thought of from technology, from a base cell level to pack integration. Like, can you actually get this thing into a module? And then is it even cost effective to do so, right? I tend to do that right up front. So when customers engage, it's a very, very seamless process all the way through. So it's a pleasure to be here.
It's a pleasure to have you. So let's start with just talking about Amprius and what it is that you all do for your customers.
Yeah, so, Amprius Technologies, the best way I can summarize it is this, right? So we are the most advanced commercially available lithium-ion batteries in the world today. One of the things that kind of happens today is that there's a lot of talk about all these new different technologies and these different opportunities, and there's I call that a lot of market noise, and that's understandable, right? The battery industry is big; everybody needs more electrification, but when there's a reason why we've been under an incumbent graphite anode, forever, right? It's because bringing new technologies to market is incredibly difficult, right? We're the first out of the gates to successfully, really large-scale commercialize a silicon-based anode battery, right? And with silicon anodes, you're able to increase the energy density of the cell that you're using so that, in layman's terms, just improve performance on the cell, right? Our claim to fame is our third-party proven 500 watt-hour per kilogram cell, right? Which, when you compare it to the most commonly used batteries today, it's twice the energy. So you literally double the performance, right? If you want to drive, you're driving twice as far. If you want to put it into a consumer electronics, if it lasted one day before, it'll last 2 days now, right? Relatively nice that it transfers linearly that way, but that's really what we do.
That is quite significant. Naturally, to be able to make that much of an impact with a lot of silicon based. My understanding is that the reason that so many battery manufacturers haven't gone as far as it sounds like you all have is because of the properties of silicon being so brittle and being very I want to say sensitive when it comes to the thermal component, where that's been a challenge for a lot of the industry. You all have certainly cracked something, and I'm not going to ask you to divulge all of the secrets of how you did it naturally, but is there something that stands out that really was the catalyst for achieving that?
Yeah, so obviously I can't get into the real deep technical details, but let me kind of summarize the problem based off what you exactly what you said, right? So traditionally, whenever you use silicon as an anode material, what ends up happening is either you layer it on as a film, or you actually kind of group them together as particles. And what ends up happening is exactly as you say. Whenever the silicon lithiates, right, the lithium goes into basically goes into the silicon particle, and that silicon particle starts to expand, right? And then whenever you discharge it, all those the lithium ions go out and it contracts back down, and that mechanism ends up cracking. You break the silicon, right? And when you break the silicon, now you have less silicon. It breaks apart. It's no longer part of the entire anode structure. So what ends up happening is you have less silicon there for it to do it the next time, and it happens again, and so on and so forth. And what you have a phenomenon of that's measured in cycle life, right? So that whole phenomenon, what it shows, what it manifests in, as its very, very short cycle life. Okay. Amprius, we cracked the code, right? And not only do we crack the code, we did it in a way that customers can really, really appreciate. So the first thing that I would say is, not only are we able to kind of control that, we have made it so that you don't need to do anything extra to use our cells. Let me give you an example. A lot of, if not all other advanced battery solutions require a compression mechanism on the face of the battery cell. Okay, that's because they need to find a way to keep the layers from separating. Right. So with us, we actually have a way where you don't need to do that. Right. So you actually, for the by and large, you can treat our cells just like you would a normal graphite anode cell, right? If you took our cells and held it up against each other, they look and perform exactly the same. It's just we last significantly longer, right? That is really, really what has taken a hold in people's imaginations in the aviation space. And I know we generally talk about EVs, but if you can imagine, right? If you have an incredible incredible battery cell, okay, I'm going to make up a number, 1,000 watt hours per kilogram, right? Incredibly, incredibly energy dense, but you need to put a brick around it to compress it down to actually get it to perform. Well, you've lost all of your advantage by putting it into an airplane, going to get it up in the air, right? So for us, you can take our cells, minimal, normal packaging around it, into a module and get it into the airplane. So the gravimetric energy penalty for using our technology is minimized as much as possible, right? So all of these things, is really what's driven the market to us.
That is a very excellent point that I'm glad you brought that up, because a lot of cell manufacturers will certainly tout their numbers on the cell level.
That's right.
But we don't use battery cells, we use battery packs, and the packs go into some sort of structure outside of that even. And
That's
all
right.
of that needs to be taken into account when you're designing systems. So with airplanes, naturally, for most of my audience, I'm sure they're probably not necessarily experts in aerodynamics, but on a basic level, your thrust needs to overcome drag, and lift needs to overcome whatever the opposite of lift is, which is escaping me at the current moment. But in order for an airplane to fly, you need to have the lift exceed, I'll call it weight. So the force, gravity pulling you down, lift needs to exceed that. Well, if you weigh more, gravity is going to be pulling on the airplane more. Therefore, you need more power in order to move forward to create lift with the wings. There, very basic physics, aerodynamics discussion. So with batteries, and we see this in land vehicles too, the heavier the pack, the more batteries they need to put in order to achieve a certain either power level or range. With an airplane, if you run out of energy, it's a little bit more catastrophic than
A
if
little
you
more?
a lot more catastrophic than if you ran out of energy, in your car and had to pull to the side of the road. Not that that even happens all that often anyway, but certainly in the aviation industry, it's it's not that it can't happen often, it's that it can't happen. So starting at the cell level to have the lightest weight, most energy dense from a volumetric standpoint, because obviously you're limited. It's not going to be the biggest airplane in the world, but gravimetric density being at 500. You said 500 watt hours per kilogram.
Yes.
Yeah, like that's very 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 important. But then to build the pack with the battery management system, thermal, whether it's coolant lines and liquid cooling, um, all of that needs to get designed. And I'm imagining that generally that gets put either at the bottom of the fuselage or in the wings where traditionally the fuel tanks would be. Gosh, that unlocks a lot. Let's talk about application of the technology, and you don't have to necessarily say any customers that are using this currently, but if you can give a couple of examples of how this is being used in the aviation industry right now.
Yeah, so you actually touched upon a lot there, Zach, and I'm trying to think, how do I kind of slice that up to kind of really kind of go about it. So let me kind of start with this, right? So you're exactly right, right? So when you're talking about trying to electrify aviation and trying to get the power necessary to really kind of get up there, and what it's actually going to kind of take to kind of get all this, get the system and then the product and everything ready to kind of get up in the air. Gravimetric energy density is where everything is at, right? Because if you're just talking on a cell, that's great. But if the more you add, if the cell gets incredibly hot, then you need to add a cooling system, which is more weight to your proposed solution, right? So for Amprius, we've been very, very cognizant of the end user application, right? The aviation and aerospace is one of our key market segments, but it's by far the most obvious one because all of our properties is perfect for this industry, right? So let me kind of first start talking about it, right? So the temperature range of our cells is -30 to 55 degrees for ambient temperatures, right? Our cells can get hotter than that, but sorry, I'm talking about centigrade, so
Yeah,
Celsius. Yeah.
that was like
So
55 degrees Fahrenheit wouldn't work.
Fahrenheit, I'm
So
like, that's not
clearly,
too good.
clearly
Yeah.
centigrade.
Centigrade.
Yes.
Yes. So very industry standard lithium ion temperature ranges, right? So again, when people start talking about all these different technologies, yes, it can do this at a very, very narrow temperature range, right? Like you have to, super cool it to get it to do. I mean, there's so many misperceptions about information that's offered up, right? Because people do it because they want people to get excited, right? So for us, we have the cell. This is the performance of the cell, right?
Mhm.
And in ambient conditions, you're going to get exactly as we specify, right? And then we have a very wide range of products in our portfolio. It's not just one product for everything. So, there are multiple attributes to a battery cell that you have to consider, even when you're doing EVs, right? Like, what are you really looking for, right? So, fixed wing applications tend to not need as much power, whereas vertical takeoff and landing ones need much, much more power. Okay.
Yep.
So we have different cells in our portfolio that are really kind of catered towards your application. Do you really need more power, or do you really, really want energy, right? So that's the first part. Now, to get to your statement about, hey, if you run out of energy in the air, it's more important than if you run out of energy on the side of the road. Yeah, right. I mean, that is by far the biggest thing. And so what a lot of people, well, actually, your audience should certainly know this, but a lot of people don't understand is even in your electric car today, right? When you say, I'm going to run it from 100% all the way down to zero. Well, whenever it got down to zero, it's actually not zero. The cell actually has some reserve energy in there. It's just not usable for you, right? That's your energy reserve. Okay. In the aviation space, that is significantly more important because they need to be able to have enough energy in reserve for a emergency abort procedure. So generally speaking, right, if you're just flying and everything's fine and you're landing, right? So the idea is to go as far as you possibly can on your battery. That's how you maximize your value proposition. But when you get to your end distance and you kind of come down and something happens, right? And you need to abort landing. Suddenly you need a very, very large thrust of power and you need to be able to kind of come up, circle around, and come back down again, right? You must have enough reserve energy and power to do that, okay? So that right there, okay, that condition must be met by every technology that is going to be put on into an aviation aircraft, okay? So using conventional batteries, if you think about it, the energy and density that they have then is even less, right? They can only utilize 20, maybe 30, they can only utilize 70, maybe 80% of that battery, right, for actual usable energy. So if you can imagine now with Amprius's, much, much higher energy density, you're able to actually keep that in reserve and still have all the usable energy that allows you to kind of get the distances that you're looking for. In terms of application, other than the public companies that that allow us to use their names, that's Airbus, Teledyne FLIR, AeroVironment, BAE Systems, et cetera, et cetera. They don't like us to say their names. Why? Because they have a significant competitive advantage in the market, right? When you take a drone and you put our batteries in it and you fly it, and for any sort of, hey, we're going to have a fly off to win a contract, well, everyone's flying 30 minutes, and you come up and you fly 50 minutes, instantaneously you're the winner, right? So companies tend to like that, right? The continuously winning contracts, so they tend to keep they kind of want to kind of keep that out of the news so they can hold on to that as long as they can. Right. In terms of application, what I can say is this. What I don't like to do is, sell people on our performance. Like, oh, let me tell you how great we are, right? Because that's what everybody does. Every business development person on earth, that's their job, right? Is to make their product shine as much as possible, right? I don't do that. I say, we have actual customer field data that I can show you, right? This is our product. This is their product before. This is their product after, right? Using our batteries. They've changed nothing else other than the battery system, okay? And look at the flight data. Look at the flight times, right? In some cases, and this is kind of weird because there's a lot of optimization, but in some cases, flight times more than double, right? So they were flying 30 minutes before, they're over 60 minutes now. It has a lot to do with the fact that you can optimize for weight, and then you can actually optimize the craft a little bit more, without redesigning, but optimizing it to get, better performance, right? So yeah, I mean, some of the field data that we get back is incredible, right? So that's what Amprius hangs our hat on. We don't do. I think your viewer base can laugh, right? We don't do much marketing, right? We're not a marketing company, right? We are a cell manufacturer, right? And we have our reputation by actual application, right? People in the industry talk. Right. And, all these different conferences, everybody walks around. Yeah. And when you have something that did really, really well, it's like, how did you do that? Like, what in the world? And, they like to brag, like, yeah, man, have you heard of Amprius? And then immediately, hey, we heard from so-and-so that blah, blah, blah. Can you help us too? Of course, let's talk. Right. And it just kind of snowballs that way.
Yeah. While the aviation industry, or even electrification as a whole, regardless of what type of vehicle, it might seem really big to people on the outside, but it really isn't. You've got like it's like a small village of key players that are out there really pushing the advancement. So yeah, word will get around if there's something out there that's going to nearly or double or more than double the performance that they have been getting previously. I don't think that's going to be kept a secret for very long anyway.
Exactly.
So with the current use cases, is that something that members of the general public, for example, those listening in the audience, is that something that they would have been on an airplane that has used that, or are we still, do you feel, maybe a little ways out before that'll happen?
The short answer to that is no. Commercial airliners, commercial crafts like that, not really no. They're used to kind of optimize, the electrification for things that are not for propulsion. Right. So, but we're much closer to that than people actually understand and know. Okay. Already you are seeing electrified aircrafts for smaller manned vehicles, particularly fixed wings, right? Like, we're talking, Cessnas, things like that.
Things with propellers.
Yes, right.
Yes.
I mean, and almost, if it's going to be electrified, it has to have propellers, right? You don't get combustion jet engines that way. Right. So yes, for propellers, but really they're for smaller aircraft. So two-seaters, at most four-seaters, fixed wings that are going. You already have those electrified aircrafts today,
Yes.
right? It's as you start to improve upon those and then get people more comfortable with it, because there is a at least for me, an understood concern about, I'm getting into an electric airplane. This is very, very new. It's the same thing that happened whenever people first started getting electric cars, right? It's like, I don't know how this is gonna, is this gonna be reliable? Like, what is this, right?
Right.
There's a lot of kind of uncertainty about it, but it's going to become more and more prominent. Okay, then you have other players, in the vertical takeoff and landing space, right? A couple famous one, Joby, Archer, Ehang over there in China. Like, there's a lot of vertical takeoff and landing crafts today that are, I would say, significantly more closer to commercial operations than people realize. I've always said this. There are certain countries that are much, much more lenient on regulations because they want to be perceived as leaders in industries, et cetera, et cetera.
Right.
You're going to see these crafts in operations in these cities in the near term, right? I can't speak for the other companies, but I know they're trying to go as fast as they possibly can to demonstrate that these crafts are real, they're safe, they're capable, right? And as that becomes more of a normal part of life, you'll see it start to kind of expand out, and more places are going to have it. You're definitely going to see it in urban cities first, right? Just think of the gridlock, over
Right.
in New York, right? So, I mean, imagine being able to get from JFK to the middle of New York City in 15 minutes, right? I mean, something like that. I mean, people are like, oh my, I couldn't hail a cab in 15 minutes, right? Exactly. So, things like that, right? I mean, when you introduce a life-changing product, right? When I say life-changing, it literally you redefine what's possible in your head, right? Mm-hmm. When you start to do that, suddenly it's like, oh yeah, this is really, really great. This is really, really great. And then you'll see it proliferate more, right? But it is coming. It is absolutely coming.
So all of those futuristic movies with flying vehicles and taxis, like, I'm thinking in my head, The Fifth Element, if you know,
yes.
Like,
yes,
that kind of thing, like where it won't just be congestion on the ground, that we'll have to worry about the air too.
Yeah, exactly. I was worried you're going to say the Jetsons, because everyone thinks that's the first thing people go. It's like, oh, it's a jet. It's like, nah, it's not going to fold into a briefcase, but it's gonna,
maybe someday. Who knows?
Maybe someday, exactly.
But they have to make that sound.
I'm sorry. Yeah, exactly. Right. No, all joking aside, we are right at the beginning of that transition, right? The products exist, the technologies exist, everything is there. It's about getting it all together and bringing it to market and get people, getting the early adopters much more comfortable with it, because even early adopters are like, I'm excited, but man, I'm nervous, right?
Right.
But when it becomes commonplace, right, then it's, you know, like, I'll give you the easiest example, right? Uber, just a ride sharing service, right? When they first started off, people were like, this is weird, right? I don't really, what is this, right? But it's now commonplace, right? Oh, grab an Uber, let's go,
Yeah.
right? That's kind of what's going to happen, right? It's going to come in, people are like, what is this? And then they're like, wow, this is really great. That was really convenient. That was wonderful. More and more and more people adopt.
Right. Right. And I imagine even outside of the industry where it touches consumers in terms of them being passengers, there is maybe even more opportunity for the aviation industry outside of that with moving goods. So
Oh,
you had,
absolutely.
you had mentioned
Absolutely.
drones. I know there's been so much talk about doing package deliveries with drones. But
Yes.
at least from my perspective, it doesn't seem like that has necessarily come to fruition yet, where I have not seen that or heard about that being done. But I would imagine that would almost be a starting point before the passenger service aspect of it, because if something does fall out of the sky, well, okay, you might have lost a package, but it probably won't make the news
Yeah,
necessarily,
exactly.
which obviously you want to avoid as an industry. So if we're close to VTOL taxis as an example, how close are we, or are we already seeing a lot of unmanned flight using the batteries and the cells that you all are using?
I mean, that's a great question, Zach. So the answer to your that exact question is it's way advanced. The unmanned aerial vehicle space is like it's essentially what is really ramping up, right? Drone. I can talk about drone delivery. I can talk about agriculture. I can talk about what is really prevalent in Southern California right now, the fires, right? How do you fight fires with like the what unmanned aerial vehicles can allow you to do? The amount of ingenuity and creativeness is incredible, right? But whenever you are hampered by your what you can do in terms of power, right? About in terms of how long can you fly, that makes it really difficult. Okay, with regards to drone deliveries, right? That that the first person to ever call that out was Amazon Prime Air,
Right.
right? Interestingly, I was part of that initial team, right when it was an initial concept, right?
Yep.
But many other players are in that space already, right? And there are that specific industry, like everything, it's a business, right? So you have to find a way to make it cost effective to move from the current incumbent solution, which is you have drivers and trucks moving around, to having a drone deliver, right? And there are metrics that I know of that I can't repeat on here, but they need to, anybody with a little bit of sleuthing can kind of get there. But on a cost per delivery basis, right? The unit cost on a drone today, right now, is significantly higher than hiring a guy to drive around in a large, van moving, cargo to house to house.
Right.
But that is starting to come down. Okay,
Sure.
and the moment you see it hit parity is where you're going to see a lot of these delivery drones kind of go out there.
Mhm.
That is coming too. Okay. The other part is, agriculture, safety, all of these things. Uh,
Military?
yeah, absolutely, right. I mean, these are all the things that that it's in a sweet spot for a battery technology that gives you high gravimetric energy density, high, energy density. Period. Right. I mean, what we effectively allow you to do, I mean, you can really start to let your imagination go wild, right? So, if it's a matter of, hey, my drone can survey an area for 30 minutes before it has to come back in, right? The time that you're kind of coming back in to kind of come down to have something else come back out, that is value time that you're losing, right? So it's not just about the radius that you're kind of out there. It's how long can you stay out there? right? So for us, if we're able to allow you to increase your mission time, if you will,
Yep.
it's much more valuable than just, oh, I'm getting a little bit extra time, right? It's, you don't need to recall something back in, right? You can stay on mission for longer. For what you said in terms of military, right? If you can imagine, right now you have a lot of drones that are used to protect the men and women of our armed forces, right? They survey the area. You know, from before it was I call it the bird's eye view, right? You're looking down on things like that. But in certain circumstances like that, you don't, if they're underneath a canopy, something like, you have no idea what's underneath there, right?
Right.
Now you have drones where they can do recon on an eye level, right? So they can go around, you can see, is there something waiting for me or and my team if we're going, if we're going to go
Right
in,
around the corner.
right? That's right. And if your device can only go for 10 minutes, right? There's a problem, right? Obviously, you can't be carrying this huge drone around. They have to be small. They have to be usable, right? So the great thing about Amprius' technology is that it's applicable, right? You can make it big, you can make it small. You're just basically increasing the incumbent runtime,
Sure.
right? So if before you only had 10 or 15 minutes of usable time, as a guy, you're like, okay, let me get the drone out and let me fly it, but I got to be pretty close because I only got 10 minutes before this thing is dropping out of the sky. Well, if you go to us, and now you got 20 minutes, right? And so now you get 20 minutes of additional mission time, right? So let's just let people really grasp that, right? 5 minutes. If you were 10 minutes before, okay, that means you have 2 minutes of distance for you to fly to get to your point, okay, and you got to fly back, so that's another 2 minutes. So you're left with 6 minutes to actually do anything, right? Now, if it's 20 minutes, okay, what I've effectively done is it's 2 minutes there, 2 minutes back. You have 16 minutes that you can be out there. That additional 10 minutes is phenomenal in terms of what you can actually do with it, right? That's the game-changing performance that we allow, right? We're taking products to a whole nother use case level. Things that are like, man, I wish I had this before, right? That's what we do.
So it's interesting. You were saying that, and it occurred to me that advancements in gravimetric density for that kind of use case actually have they serve to an additional benefit that, let's say you are with a group that's trying to penetrate a certain area on a battlefield or in an urban warfare environment. You don't want your location to be known. So if you are using a drone, and usually drones only have roughly a 5-minute time before they have to turn around, if the enemy sees that drone, they know you're close. You're within 5 minutes because you're not going to just let it drop and it's not a throwaway device.
That's right. That's
but
exactly right.
if you're able to double that, especially if the enemy doesn't know that, well, now they're going to make assumptions as to your location that are incorrect, where you haven't compromised your situation. And in many ways, it could add some confusion to the other side, giving you an element of surprise. Like there is, from a tactical standpoint, just changing the gravimetric density of the cells has such a wide impact in that type of environment on many different levels.
That's exactly right. I mean, let me give you a really rudimentary example of this, but using old kind of known technology. So the bow and arrow, right? When the bow and arrow was first introduced, it was revolutionary because it allowed you to attack an enemy at a distance, right? You didn't have to do armed combat, right? But what happened? The other side got bows and arrows, right? And they're all kind of the same bows and arrows. So, you're if I can hit you, you can hit me. So let's just stay, a foot behind that distance radius, right? So what happened then? Then they went, okay, well now let's get longbowmen, right? Yep. So now I've now pulled it is, I can hit you, you can't hit me at all. So I can actually get, be much better positioned because the moment you come into my radius, you're in a lot of trouble. Okay.
We've got the longbow.
Yeah, exactly. We've got the longbow, right? We've now allowed the men and women of of our armed forces, right? Like our technology allows you to just, be safe, right? Like their lives are important. That's what
Yep.
matters, right? How can we accomplish a mission with as little risk as possible, right? And if we can do it with no risk, absolutely, right?
Yeah.
That's what we're aiming for. And you got it exactly. What we're able to do. This is the concept of, man, gravimetric energy density is really important, not just because of the runtime. It's what does that really mean?
hmm Um, you had mentioned that in addition to having that energy to be used for lengthening flight times or range, that also you could have things that are designed specifically from a power aspect. So I don't understand, or it's never come up and I haven't looked into it, the relationship between anode design and a cell's C rating. Are you able to touch on the technical side of that? And then maybe we can kind of take it from there. Does that allow for additional benefits from a power delivery as well as charging speed side of things as well?
Yeah. So, uh, I'm trying to see like what I can really kind of disclose there, right? Maybe I'll stay away
Sure.
from the technical piece and
Okay.
just really kind of get to exactly what we have, right? So, um, traditionally, whenever you're talking about a silicon anode, as we kind of discussed before, you really want to treat it nicely, right? You want to let that expansion and contraction be really, 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 really light, so you're hurting the cell as little as possible. That translates to low C rates, right? C over 5, C over 2, at most
Sure.
1 C. Um, we have product offerings right now today, January 21, commercially available that does 5C continuous, right? 8C pulse. It can be higher if you wanted to, but this is all with no cooling, no compression. You can buy it today, right? We just did a press release about our ultra high power, high energy cell. That's 10C continuous and even higher for pulse. Again, no additional cooling to make it necessary for it to be able to be used.
Right.
Okay. Now, historically, if you get power, you got to give it up somewhere else, right? And that's usually in terms of energy density, right? If you look at the cells that are out there in the market today, the higher the C rating, the lower the energy density of that cell is going to be. Okay. What made this cell so impactful to both the aviation industry and the electric vehicle industry is that it still maintains incredibly high energy. So this is a game that people play, right? So when they say, "Oh man, my cell this," let me do this. Let me give you the specifications, and then let me tell you how people game that and how we did not. Okay. So the cell that we just introduced, it's 370 watt hours per kilogram, 10C continuous capable, at least 15C pulse, right, with no cooling. Okay. Now, right there, people go, shit, yeah, exactly what you did. Wow, right? Like immediately, like, wow, that's amazing, right? 10C, 370 watt hours per kilogram. That's amazing. Well, what most people do is they quote the energy density at C/5. All right. And as you are increasing the discharge rate, the energy density falls, right? If you're discharging at 10C, you're not getting 370 watt hours per kilogram. Just like if you're discharging, for any cell, right? When
Right.
you go and you look at industry leaders, I don't need to name names, but you look at them, their rating is based off of C/5. Okay. This cell, C/5, 370 watt hours per kilogram. Wow. At 10C continuous, it's still over 300 watt hours per kilogram. That's when people go,
Yeah.
whoa, right? At 10C continuous discharge, this cell's gravimetric energy density is higher than traditional power cells at C/5.
So now I'm
That
top fuel dragster type, like
There you go.
drag
There
racing
you go.
applications where you need that immense amount of power, but only for 5 to 10 seconds. Oh my goodness, my mind is going all sorts of places with this. That is incredible.
Exactly, right. So we have the things that Amprius does is amazing. Okay, the things that we are bringing to market, right? So here's the next part, right? People make these claims of, oh, we got this, right? And generally speaking, they're foreshadowing something that they kind of did in a lab that they're trying to figure out how to do it, whatever. This is a cell that we intend to bring to market within this year, widespread commercially available, right? So Amprius's reputation, it's not about claiming the different technology breakthroughs. It's we are a commercial manufacturer of batteries. Right. And what we say, we're going to bring to you, and they're going to be ready and available, right? And that's why, this announcement, I got a flood of calls. It's like, hey, this looks really good. It's like, yeah, it is, right? So, again, if you can imagine the power capabilities of this cell, what it enables, right? Now, if you're talking about the devastation in Los Angeles, right? If you can imagine carrying, a drone carrying sand or carrying water, that's a heavy payload that you're trying to sit there and do, right? You need a lot of power to be able to do that, right? That's what this enables, right? So now instead of being able to do, 2 flights, dropping, and then now you're going back in to try to recharge. Now you're doing, 3 or 4 drops before you kind of so continuous runs like that. And then, of course, it's translates, for us at least, it translates to the same thing for charge time, right?
Well, yeah, that's
right. So
where my brain was going next. You're right on.
Exactly, right? So it's great to be able to do this, but if you got to come in and you got to charge for 8 hours before you can kind of get there, and it kind of takes the wind out of the sails a little bit, right? So we know that we live in an impatient society, right? Nobody wants to wait. So, before, everybody knows this, right? Consumer electronics is, actually, people don't know this. Consumer electronics is typically C over 5 charge, right? You need 5 hours to charge it up, right? Then it became, look, we really need fast charge. We really need like 1C, right? Charge it within an hour. And right now it's, hey, 20 minutes. Like they really want 20 minutes, right? 4C, right? 3C, right? They really want that 20 minutes, right? And so we understand that. So our power cells are designed for fast charge, right? We're generally under 10 minutes.
So 6C or greater. Yeah.
That's right.
Which is compared to anything else that I've been aware of is extreme. And I mean, for everything that we've already mentioned, to have that kind of turnaround, where if you have 20 to 30 minutes of usage and even 15 minutes, like half of the usage time, to be able to go and charge it and then get it back out there, like rapid deployment of various devices using these is incredible.
Exactly. And so it would behoove me not to kind of mention this, but we've proven our 8C continuous charge, right? Like we have cells that are designed for incredibly fast charge, right? Yeah. But again, there are trade-offs, right? So depending on what cell, I mean, we're talking about a very specific cell right now, so I'm kind of referencing around there. But sure. But we understand that there is a very, very significant benefit to fast charging. So that's always part of our design equation whenever we're coming up with new products here at Amprius.
And of course, that doesn't mean it has to be charged that quickly, where you could always charge it slower if you wanted to, and then obviously your cycle life and usable life of the product is extended. But to have the capability to be able to be applied in that way is of critical importance in a lot of ways, I would imagine. I want to step back just slightly because when you were talking about Amprius reputation, where I want to repeat that back to make sure I understand that in a way that you were intending to communicate it. What I heard you say was basically that you all aren't just a lab trying to do research and development and have something to go, look what we discovered that we can do here on this bench. You all are going, yeah, we did that. But now we're applying this to be able to go, you can use this, and you being your customers. So when you're bringing something or making an announcement, bringing something to market, you're bringing it to market. It is all the R&D and going through and doing all the studies and reliability tests and quality control and everything. That's done.
That's
Now,
right.
how do we make these at scale, which has been one of the things that I've had such an issue with, and I won't name companies either, but
Yeah.
companies that they will make an announcement, whether it's solid state or any other breakthrough in battery technology, and then maybe they're publicly traded, maybe not. If they are, I've seen their stocks soar and then crash, and 5 years later they're barely a whisper. Nothing ever came from it that we've seen. And you're going, I feel like, even not necessarily as I was going to be a consumer of whatever they were trying to sell anyway, but I feel like, well, gosh, you got my hopes up, and now, So I really appreciate you all and the approach you're taking, because it's like, no, you're not just blowing smoke up. You've got something tangible that actually can be applied, and in many ways, I think that is what is needed to push the industry forward. But even for that to be talked about, because if that's happening behind the scenes, that's great and that's important, and certainly, most of the world happens without people being aware of it. But I think what you've shared with me, and therefore the audience today, I think that's important, that it is shared. I think it's important for people to hear this.
Yeah, Zach, please allow me to step on my soapbox for a moment.
Step on up.
This is that, yeah. I mean, this is something that I personally really struggle with, right? Because number one, what you talked about, it frustrates me to no end because it leads to mass market confusion, right? There's so many things being talked about, and nobody really knows, like, is that really coming down the pipe? Like, what is going on, right? And on that side, like, it's very, very frustrating. But at the same time, I understand why they do it, right? It's because there are a lot of ideas. None of them are bad ideas. They're ideas, right? And they need funding. And it's a fight for money, right? So you have to sit there and scream from the rooftops of, oh, I've got this, blah, 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 to get investors excited, to want to invest in you, to give you enough funding to make it to the next step, blah, 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 blah. But where I personally have really strong heartburn is when you're misrepresenting how far along the TRL scale that you are at, and the PRL scale, right? Technology readiness level, the production readiness level. Just this is that was a metric that was made by NASA just so you can weed out, like, what is, I don't want to say trash, but what is misrepresented, right? Because if you're a TRL 9, you gotta prove it. If you're a PRL 9, you gotta prove it, right? And so that is what's missing on a lot of these announcements, right? And so from my perspective, right, I've tried very, very hard to make sure Amprius's reputation is, yeah, they are, the things that they talk about, that's TRL 9. Okay, the products they're talking about commercial, that's PRL 9. They've scaled. This is up, like, this is going, right? You don't need to wonder, hey, is this cell even going to hit the market? Yeah, if you want a the best battery cells in the world right now for your drone, you can go to Upgrade Energy or Titan Batteries, plug for those guys, and just buy it right commercial off the shelf. Like, click, 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 you can get it, and then you'll get Amprius cells that you can just, for the most part, plug right into your drone and fly, right? That's the beauty of this, right? We're trying very, very hard to change the perception of the market, right? Not everybody is just all talk and no product, right?
Sure.
We're first out of the gates with product at scale, right? And it's not just sort of good, we're really good.
That is, I think, a great way to bring things full circle. Because one of the very first things that you said was that you had the best commercially available batteries. And at the time in my head, I'm going, what does Ronnie mean by the best commercial? Like in my head, I'm going, okay, well, we'll see. Um, I think over the course of our conversation here that the question I had in my head originally has very thoroughly been answered, and it's exciting. And I've learned that sometimes I have to hold back on my excitement that I naturally feel because of the reasons that we said that that sounds great, but it might not ever happen. Um, I don't think I need to hold back because I'm like, man, this is great. So then obviously what the next step is, I mean, economies of scale is what will bring costs down. Do you see a future where the cells that Amprius is building and designing are available to anybody, like to me, where I could just go and say, hey, I need I'll use 18650 as a form factor because that's so incredibly common, but I need some 18650s and I want them to have these capabilities. And yeah, I just go to this store online, most likely, and buy them.
So, generally speaking, I mean, yes, we're a lot closer to that than it is. Like we don't do our own B to C kind of
Right.
portal, but we have if you want to say 18650, we have a 4 amp hour 18650 commercially available that you can go buy today, right? I have a 6 amp hour 21700 that you can go buy today, right? And you can we do have partners that can do it. um they're not a technically a reseller of ourselves, but they purchase a lot because they build packs, right? So if you're like, hey, if you contact them, I'm sure that they would be willing to work with you to kind of figure out, hey, how can I get you cells in the future? Yeah, I mean, what is it? There are websites that just sell you cells, right?
Right.
We're not a commodity place, so I don't particularly like doing this, but yeah, we could list on Amazon.com, give them a huge chunk of their fee, right? And make it super expensive, but you can list it on these web portals and get them available onto the market that way. But that's not how we work, right? Again,
But it doesn't sound like you need to do that.
that's right.
So like there isn't a reason from a business case standpoint that you all would be like, oh yes, we are going to do this. You probably have enough um, outside of that to satisfy just the capability of what you're able to produce for, I would imagine, many years to come.
That's right. I mean, it obviously it's part of my job to really understand the market dynamics and what we kind of need to do. But no, for us, right, it's a matter of, like even with us. So sorry, let me take a step back, right? So even with us, right, we have such a reputation in the industry of, man, these guys are legit. These guys are real. But even then, when new customers engage, they're very cautious. It's like, is it really, right? Because it's so far beyond what they're used to, right? I have
Right.
stories from people that say, look, I actually saw your data sheet 2 years ago, but I crumpled up and threw it away because I thought it was fake,
Right.
right? But
Very
I
fair.
just got validation that this is real. So let's talk, right? So it's they're still warming up to the fact that, wow, next generation batteries are here now, commercially available, right? Price, market competitive, like all of the, like, they're still wrapping their head around it and they're getting excited, right?
Sure.
So I like to think of us as kind of the pioneers of the silicon anode battery, right? We're the first out of the gates. It's going to take hold, right? The benefits speak for themselves, right? And the world needs them, and that's what we're trying to do. We're trying to make sure that we apply our specific technology to the people who really, really need it and can really help them bring game changing, revolutionary changes to products, right? Things that they people with products wish they can do but are limited today.
Right. And the battery, in many ways, is the one component in the entire system that has the capability of making technological leaps and bounds in terms of improvements compared to I mean, anything else. Um,
Yeah, you're talking about
yeah,
efficiencies, right? That, I mean,
yeah,
you know, you can sit there and if you like, and let me stick with the aviation space or the unmanned aerial vehicles space, right? So you can work on aerodynamics, right? You can try to redesign that thing to get you better aerodynamics when you're moving forward, blah blah, and you're going to get like a 1 to 2%
right.
efficiency increase. Whereas if you change over to an Amprius battery, you're a 30% increase, 50, 70% increase. Just like, okay, right? Like, no amount of ingenuity is going to give you that level of performance increase, right? That's really what it is.
Talking with you today, Ronnie, has certainly expanded my understanding of reality in terms of what's possible in the near term. And so I want to thank you for that for myself personally, but also what I've learned about my audience is if I'm thinking something or feeling something or be like my mind being blown about something, well, I know I'm not the only one. I know there's a
Sure.
lot of other people that are going to watch or listen to our conversation that are going to have a similar reaction. For them, what is the best way that they can monitor, follow along, keep tabs with what you all are doing? Is it as simple as going to the web page, or would you recommend people follow along in a different method?
So right now, our communications, like I said, we're not a big marketing company, but certainly, do a. I mean, there are alerts to let you know when web pages are kind of update. Definitely do that. Right. Keep an eye on our announcements because our announcements are very strategic. Certainly jump on our social media. We do have LinkedIn. We are on YouTube. A little bit light on video content, but regardless, we do try to do in the social media channels just to let people know kind of what is generally happening. Um, you know, Being who we are typically bound by a lot of NDAs, so we can't. We're never really able to be really specific, but just you can see from the trajectory of our company what we've been able to do, what we are continuing to do. Um, you know, when we have a product announcement like we just did, right? Take a moment, aside from the wow factor of, oh my gosh, this is because it always is, right? Otherwise we wouldn't announce it. But the take a moment, wow, this is amazing, and then take a step back and just go, why did they even make this, right? And try to apply it
Yeah.
and be like, what does this do? What does this enable, right? And that'll start to kind of paint the picture of, I see. This is how Amprius is trying to help industries. This is how Amprius is trying to move the needle, right? And hell, man, if it's for something that you thought of, that anybody in your audience thought of, that oh, it'd be great for it. Feedback, man. Like we make announcements on LinkedIn. It's like, yeah, you should apply this for whatever, right? I'll send my team to go investigate it. Maybe we'll maybe we thought of it, maybe we did it, right? And if we didn't, then we'll go find the relevant person and get it into that industry, right? That's really what I would recommend.
Awesome. Excellent. Well, certainly I would encourage everybody to follow the company on LinkedIn and stay connected in that way. I think the important announcements or the buzzword is breakthrough, but
Yeah,
the advancement of technology, we'll say it that way, certainly isn't over. And I
no,
have a feeling that in the coming years we're going to hear lots of really exciting, awesome things coming from you all. Before we end our conversation, sadly, um, I traditionally have two questions I like to ask my guests, and this does turn the spotlight more towards you versus towards the company or the technology. Um, the first of the questions is arbitrarily, what do you drive in terms of what gets you around from place to place?
I drive an electric vehicle, fully electric, not a hybrid, fully electric. No free pub with me, so no free publicity. So, well-known brand, very very reliable, very very good. Yeah, a fully electric car.
Awesome. And the second question is second or rather, the first question was first because I use the word drive and play around with that. So instead of what do you drive, and I have a feeling you are going to be able to answer this very easily. What drives you? So when you wake up in the morning, what's your passion? What's your purpose? What really keeps you going?
Let me answer this. The kind of like, again, as you said, full circle, a little bit about me. Okay. As I said, I've kind of been on every kind of side of a battery. I've been integral to the launch of some very, very unique products. I don't want to call them out here. That's still relatively secretive, but I've been in this space for a long time. Doing another phone is not fun for me. Doing another tablet is not fun for me. Okay. Enabling wireless communications in remote areas of Africa without having to run power lines through everything to kind of get it to these places, that excites me, right? Being able to apply myself to a technology or to a cause. I call this a cause, but being able to apply myself to a cause to enable real life changing events, right? We didn't talk about much about it, but they're called high altitude pseudo satellites, right? What I always kind of talk about is, if you reference, I'm a lot older than I look, but if you reference some of like the older movies, like Apocalypse Now, and like they're in the jungle. And there's one guy with a lead acid battery with a sat phone on his back. Like he's literally just running around the telephone booth, right?
Right.
Like that's his job. Run around, carry a lead acid battery, run around like that, right? And you have one guy who's able to communicate. That's it. Okay. High altitude pseudo satellites. We're kind of doing a lot of kind of different things. But if you can imagine, there's Starlink. There's all these, but those are stationary orbit satellites that kind of go around. High altitude pseudo satellites, you can actually bring them up, and they kind of stay over an area perpetually, okay, until it kind of needs to go 6 months at a time, targeting a year at a time, where it doesn't need to go down. Okay, so in that same situation, now if you can imagine Apocalypse Now, where everyone's got their cell phone out, getting a 5G signal, full data, you can call, you do FaceTime, you do all that kind of stuff, right? That is absolutely life changing. Right now, take it out of the military stuff and just bring it to remote areas of the world. People who don't have access to the things that we take advantage of every single day, right? Power, communications, things like that. Obviously, we're not providing the power, but we provide things that allow for those other things, right? So if we can enable a high altitude pseudo satellite to stay up in the air for a year, right, and then they can deploy it into those regions. The cost to do that is so much lower and so much easier to do than it is to, okay, let's figure out how do you just sit there and do polls and put it over mountain ranges as we're running lines across. So like, you've changed the world. That's what drives me.
Yep. And you mentioned aerospace, and now I remember thinking, what? But now it makes sense.
There you go.
I've found that the people that I've had the great opportunity to speak with on this podcast, which a wide array of so many different people in various aspects of the industry, and the companies that I have found belief in, it have been the ones that their focus, their purpose is in changing the world and making things better for other people. The focus isn't so squarely on the technology. The technology and advancements of such is just a tool to help move humanity forward. And
right.
I truly, truly get that from you. Absolutely. And the way you describe not just what you're doing, but I would imagine, even though we didn't really get into company culture, but I would imagine that you wouldn't be saying those things if the company wasn't also aligned with that type of vision and how you're looking at things. And so that's not lost on me. And I definitely want to make sure I say that so that the audience can kind of really grasp that if they haven't already, which I'm sure most already have.
I like to say that I am the forward-facing representation of our company values.
Well, I believe you've done a really good job of that. So I
Well,
want
thank
to
you.
thank
Appreciate
you for your time and your conversation. I mean, really, you've opened my eyes to a lot. Which this is one of the reasons I love doing this podcast. Is I'm a geek for technology and changing the world and making it a better place. So I love having these conversations. But um, from my perspective, I think I wouldn't do this and keep it to myself. Where it's
Right.
like I have to share this because it's so important, and I really truly believe that people need to know. So, yeah, I can't wait to get this out there and have everybody watching and listening, and get as much out of this, I hope, or maybe more than I have. So, thank you so much for being here and spending your time to share with us.
Oh, it's been my pleasure, Zach.
I really hope you've enjoyed this podcast and want to thank you so much for being here. If you haven't left a review or rating on Apple Podcasts or Spotify, I'd really appreciate it. And if you have any feedback for the show, questions for me, or just want to reach out and say hi, you can email me at hello@ev-resource.com. The EV Resource Podcast is a production of EvoSpark Media Group and is supported by viewers and listeners just like you. Supporters of EV Resource on Patreon include at the director tier, Rajeev, Narayan, and Andy Cooper, and at the producer tier, Eric Weber and Tony Stuntz. I've been your host, Zach Hurst. Thank you so much for watching and listening, and I'll catch you next time.